Alright, for this last video we're going to be looking at the units of energy and power. And when we look at this, the idea of energy I think is familiar to many of us because a lot of us pay energy bills to power companies. We use energy for our cars, and we always we hear arguments about alternative sources of energy, but we want to determine what is energy. So broadly speaking, energy is what makes matters move, or makes matter move or heat up. So we need energy from food to keep our hearts beating, to maintain our body temperatures, to walk and to run. Gasoline powers our car. A gasoline-powered car uses energy to move the pistons in its engine up and down, which then in turn turns your wheels. A light bulb needs energy to generate light, and so forth. And for most Americans, the most familiar energy unit in food is the calorie. And in this study, in this textbook, it says a typical adult uses about 2,500 calories of energy each day. But the international metric unit of energy is what's called the joule. So we're going to have this conversion right here, that one calorie is equal to 4,184, and joules is usually a capital J, but I'll write it out here. And so that is the idea of energy. Calories and joules tend to be what we use the most when we're dealing with Americans and food, or the international stage. The other thing, key point there, was that energy is what makes matter move or heat up. That's the foundational definition of energy. Now, there's a difference between energy and power. Sometimes these things are often used together, but they're not the same. And the power is the rate at which energy is being used. Okay, which means we're going to take energy and divide it by time. And the most common unit of power is what we call watts. And a watt is defined as 1 joule per second. Okay, so again, here's just a simple little definition box that we have here for energy and power. But again, energy and power are not the same thing. Power is energy over time, and the most common is 1 watt is 1 joule per second. And so let's look at an example here. So assume that you're riding a bike. That riding a bike burns 100 calories per minute. Okay, so that is a critical piece of information there. So if you ride at a speed of 20 miles per hour, what is the average power output in watts? So again, we're burning energy over time, so we can find the power. So the first bit of information we know is that there are 100 calories for every 1 mile. So 100 calories per mile. That was the first piece of information. The next thing is we knew that we were going 20 miles per hour. Okay, and now notice that the miles will cancel here, and we are now calories per hour, or in other words, we are units of energy over units of time, which is now in power. But to go to watts, we've got to get joules per second. So we've got to convert calories to joules and hours to seconds. So I think the most simple one first would be to go from hours to seconds. So here we know that 1 hour, again I want the hours to cancel, so that's why I'm putting up on top, is 60 minutes. And then we know that 1 minute is 60 seconds. Oops, that should be lowercase s. And so now that's going to cancel out our units, so the hours will cancel, the minutes will cancel, and we'll have seconds in the denominator there. So that is lowercase s. Now we've got to convert from calories to joules, and we knew from above that 1 calorie was 4,184 joules. So that will cancel out our calories. So now when I multiply all this out, so I'm going to do 100 times 20 times 1 times 1 times 4184 divided by 1 times 60 times 60 times 1. And in the end, I'm going to get roughly 2,324 joules per second, which is 2,324 watts. Because again, joules per second are in watts. So that is a look at power and how we can go from energy to power, where power is the rate of energy, the rate at which energy is being used. Now, one other thing about power and energy that I want to say is when we're dealing with our power bills, you'll often see what is called a kilowatt. Oops. You'll see a kilowatt hour. And when you see that little hyphen there, kilowatt hour, this just means the number of kilowatts per hour. And kilowatts per hour, well, no, I shouldn't say that. Kilowatt hours, that is not per hour. My bad. Brain was thinking of something else. Kilowatt hour, that is kilowatts times hours. And this is going to convert over to a unit of energy. So when you see kilowatt hours, that is energy, because it's kilowatts, which is energy per unit time, and then times it by hours, so that takes us back to energy. So a kilowatt hour is a unit of energy, and 1 kilowatt hour is equal to approximately 3.6 million joules. And that's what, when you get a cable, or not a cable bill, an electric bill, then you will see how many kilowatt hours you've used in your home or business, and that is what will determine, that's what they use to determine the cost, because they charge per kilowatt hour. So sorry for the hiccup there, but that is energy. Kilowatt hour is a measure of energy. Okay, last thing we're going to do, this is just one last example we're going to be looking at. We're going to be converting, using unit conversions, dealing with a diamond and its cut. So we have the Star of Africa was cut from the Cullinan diamond and weighs 530.2 carats. It is part of the British Crown Jewel Collection, and we want to know how much does the Star of Africa weigh in milligrams, in pounds, and this is just a word that is used for pounds. You don't need to have that memorized, and that's in the table. But if we look at our carats, we have 530.2 carats, and I'm going to run out of time here, so I'm going to have to hurry a little bit through this one. But if first I want to convert to milligrams, if you look up in the table, then we get this conversion, that 1 carat weighs approximately 0.2 grams. And so that'll cancel out our carats. And now we need to go from grams to milligrams. And this is where we use the metric conversion. And in that metric conversion, okay, we would have 1,000 milligrams is equivalent to 1 gram. And so that, when I multiply all that together, I'm going to get 106,040 milligrams. Okay, and that's going to be how much it would weigh in milligrams. I'm out of time to be able to do the pounds, but I'll leave that one to you to give that a try. To convert from milligrams over into pounds, I would recommend converting your milligrams to kilograms and then kilograms to pounds. But again, I've run out of time. But hopefully this helps out as we wrap up Unit 2B. If you have any questions, please do not hesitate to let me know.